Hi, Sebastian. How are you? Well, you're the first person here, so we'll wait a few minutes for everybody to join and we'll get started, okay? Thanks. Hello, Victor. How are you doing? Thanks for joining me today. We'll wait a couple minutes. Well, good. I'm glad you're having a good day. It's a little warm outside, but nevertheless, it's still a good day. So while you wait, you can check out the assignment that we have to do today. And you can bring out your Arduino kit. We're going to work on that today. George. Hi, George. How are you? Hi, Alex. How are you doing?
I'm doing good, and yourself?
I'm okay. Thanks. Just the second week. Welcome. Go ahead and check out our assignments that we have to do today. I think Ghislaine is here. Hi, Ghislaine. Hi, everyone. Okay, I think a few more people will be joining us shortly. So this is the second week of the class. We are going to finish up this class this week. I open everything until the 4th of July, and I hope you don't have to work through the 4th of July for the rest of the assignments. So I'm going to keep it light. We are going to do sensors today. Hi, Hannah. And we are going to move into some of the more project-based stuff for the lab. So I want to touch on sensor today and tomorrow. And then if you do have time, you can get started with the other stuff. So the piano and the trash can o-matic is going to be for our lab exercise. I want to remind everyone that Thursday I won't hold a live session. I will have a pre-recorded video be ready for you in case you need reference, but I'm going to touch on a lot of that for day 3, which is going to be Wednesday. Only because I'm going out of town for the weekend, and I will be landing about 1 something in Pacific Northwest, in Portland. And so I think I'm not going to be able to get access to the internet at 2 o'clock. So I will have a pre-recorded videos, and if you have any questions, you can feel free to email me, and I would respond. So it's pretty fun this week. If you have any questions, let me know. So no meeting on Thursday, okay? You're welcome to complete everything before that and turn in everything, or you can complete it throughout this week. Everything is open until 4th of July, even though our class ends on Thursday. Any question before we start? Okay. So this is the second week of Arduino, and this will wrap up our course as you finish out the activities this week. And then for those of you who are moving on to Raspberry Pi, next week we will start with embedded system with Raspberry Pi. And we will use some of the electronic components, but not very heavy like Arduino. We will do more programming inside the Pi. We will do some game. We will look at some projects that you can adapt your Pi for. And so Raspberry Pi is a little bit different where we will work with Python mostly. And so for this class now, we are just going to finish up with Sensor. Okay. So if you are on Canvas, do you have any question before we go into the lecture? Okay, I'm going to share screen. Let me enable in case you guys have questions. Okay, so I posted everything late last night or early this morning. We are going to look at the objectives. So you will have activities that you're going to work with different sensors, with capacitive sensor, which is touch, proximity, and distance sensor. So we'll touch on what type of sensors they are and how do they work. We will have one assignment tomorrow that we're going to work with the LCD. This is the 16 by 2. It's a little bit challenging in that you will need a lot of wires for LCD. And I hope that iMake Innovation Center, they gave you some male to female jumper wires. I had asked for that. I double checked my list that I sent to them. I had asked for some of the wires. I know some of you are missing some jumper wires. They are open from 7 to 5, Monday through Thursday. So if you have any issues, let me know. I can let them know that you can pick up some missing parts that you need. Okay, I see a chat comment. Give me a second. It doesn't always pop up when I'm in Zoom. Let me see. Okay. Okay, so if you're missing something, make sure that you reach out to them and let them know. Abraham is pretty good at, getting stuff ready. So, and then let me know also. I can also express it if you like. Okay, so we are gonna work with some libraries this week as we have seen some of the libraries and files. When you look at the capacitive piano one that we're going to do, it's a little bit different than using the actual sensor. You are going to make your own sensor. I have two activity for that. One is going to be just using Play-Doh and or fruits and jumper wire. The other one is going to be, if you want to draw or tape foil on the paper and using paper clip. So you are going to make your capacitive sensor, and you're going to see that as long as you have the library and the appropriate programming um, incorporated, you should be able to control your sensor. So you don't have to have the actual board. You can use conductive material to make sensors. And so we'll touch on the sensors today, okay? So we are going to refer to the handouts, which is going to be the assignment in the lab, and then I will post the video after the class. Um, and when you get a chance, there is a 5-question quiz, and I recommend looking at the PowerPoint presentation for your quiz. Some of the questions just generically comes from that. So on the next page, you will find the slide in PDF. I had shared this, so if you like, you can download it. But I'm just going to run through some of the materials so we would know. So in this week, this is going to be Arduino part 2. And when I do seminars and, activities during the summer for Cyber Camp, I usually break it down into 3 parts. I feel like even for the 2 weeks that we have, which is the maximum number of hours I can have for the non-credit course, I feel like you can benefit more for, learning a little bit more about Arduino and having more practice. But you have access to the book in your kit. And also, the internet has great resources on Arduino Hub. So I encourage you to, continue and expand your knowledge with Arduino. So last week we touched on the basics of Arduino. We are working with Uno, and it uses the Atmega 328P microchip, which is incorporated as you see. That will be under the black long chip right here. And you use Sketch, which is a program file in Arduino IDE. Most of the later library are written in C++. The earlier libraries are written in C, but keep in mind that microcontroller mostly use C, not always C++. So Arduino, you would see some stuff in C++. Most of the stuff is in C. So as long as you understand how to program C, you can expand on Arduino, and it's pretty straightforward. In one of the program that we're gonna do, which is the Play-Doh piano, you're gonna see that we can use Python file. Because the library is written in Python, we can actually incorporate that and use Python interpreter to actually make it work. And Arduino will be able to understand it. Okay. So we have the regulators that are incorporated. Most of the things we've been using are mainly coming out of 5 volts. And you do see some of the lower components would use 3.3 volts. So you would see that it has 2 regulators, the 3.3 volt, which you find on the pin, and also the 5 volt. And so the 5 volt is used for all the logic on the board, digital, especially input and output. So when you have LEDs, when you have buttons, things like that would normally require 5 volt. And then if you're using external circuitry and some of the accommodations outside of the 5 volt, we can use 3.3 volt. And if you recall on one of the circuit, when we plug in the 5 volt, it shuts off because, it prevents from shorting. So you can go with the lower voltage on that. Okay. And when we power through USB, in general, we would power it at 5 volt. But Arduino, we know that it can accept power. The safe is going to be the range between 7 volt to 12 volt. That's recommended. You can go higher than 12. So when you're looking at DC, like DC motor alone, it needs at least 9 volt to 12 volts. Anything mechanical that needs movement, especially when you use DC motor, you would require a little bit higher in voltage compared to what you see with servo, right? Servo, we can run it at 5 volt. So as you can see here, it does peak a little higher, but the recommended range is going to be between 7 and 12. Um, so for the Atmel microcontroller unit, the MCU, which is here, the Atmega 328, and if you use a different Arduino board, you will see it uses 325 or something in the family of the Atmel microcontroller unit. But for this processor, it has we use a compiler to compile our program so the processor can interpret that. So it will be able to break it down to the lower language level, the machine level, so that way it would execute the input and the output that you ask it to do based on your program. And we would interface it with USB. Therefore, you can always adapt power using a power bank with the USB. And so you do have two sides of the Arduino, the analog and the digital. And analog inputs would be between 0 volt to 5 volt, and it is multiplex for additional functionality. And then you have the digital side, which so the analog is the A's right here, right? And the digital pins over here. That's going to be from pin 2 to 13. And this is the Uno. So when you're looking at the Mega, you would have higher pin sets or more pin sets. Um, and so it talks about serial interfaces with, and most of our components we've seen so far uses pulse width modulation, including our RGB, right? So as we learned throughout our exercises last week, we saw how the pulse width modulation would work. It's a way that we can control our components. And you can also have external interrupts. So if you have an input that's external, that will be connecting to a pin, it can cause an interrupt. And what an interrupt is that it needs the attention of the processor. So it's like raising your hand in class. So that device would require the processor attention. And so it would generate a value. And that value is then submitted as a flag on the low level, and the processor would then, give its attention to that particular device. And you see this when you're using your keyboard and your mouse. So when you press your mouse button, right, it actually generates an interrupt. So when you're trying to click something while it's running another, executable application, for example, it would then generate that interrupt. So now, for the regulators, we touch on that, but in the coding of Arduino, you can use comment to provide description. That will be a multi-line comment. You would do an asterisk with a slash. The single line, you would use a double slash. So we've seen some of this in our programs in the last week. And we always start our program with variable declaration, and you would use const int, right, for most part, as you would declare your pin value. So if you're using a digital pin like pin 13, you can do int LED or const int LED equal, which is right 13. So you would need to declare those variables at the top so they are accessible under void setup or void loop, which are functions. And then you can also write your own functions, as we've done that last week with the colors of our RGB, red, green, orange, etc. Okay. And function simply is a set of code that allows you to execute a task. And we want to write functions so that way we can reuse them and we can organize our program a little bit better. So it streamlined a lot of the process for the developer. And we also use arguments, and arguments are put inside the parentheses. And you know that C and C++, at the end of your statement, you always have to have a semicolon. That's kind of like putting a period at the end of your sentence in English. So you would need to be able to finish that with the semicolon. And some of our, you would see that our command comes strictly for Arduino. So you would have pin mode, you sometimes would have digital write, digital read. Those are basically built in. Those are the command. So that way it would understand what it needs to do based on what you have passed in the parameter as well. So here we would have the parameter or the arguments, right? Here we would use the variable in the argument, and then we would have output. That means that we want to activate, we want to display that or show that or turn that on. Okay. So the second part is always going to be input and output for the digital side. And then the first part of the argument, you would have to, you can include variable that you previously declared, like int LED in the last slide. Okay, so under the loop is we understand that it needs to be executing continuously, then we would put it under void loop. Okay, and then when you see digital write, That is just going to allow us to set the state of the output for the pin. It's either going to be 5 volt for on or 0 volt for off. Okay. So when the example for this is going to be digital write, LED high, that means that it's going to turn on, right? It's going to give 5 volt to the LED pin 13, which we previously declared. And then we talked about delay, which is a wait, right? And that's in milliseconds. So we can set a value and that way we can have it wait in milliseconds. And also at the end of last week, we touched on servo motor. And servo motor, it it gives you the opportunity to program the the motor to move at a certain angle, right? We saw how we can go between 90 and 180. So it can go from 0 to 180. And it uses pulse width modulation. And so that way it can output the voltage to the servo. So if you tell it to move 90-degree, then you can set the degree and it will rotate the gear, right? And based on that, it's going to give one pulse every 1.5 milliseconds. And that's going to be able to rotate it to the degree that you have set it to go. So for the servo, for the quiz, we need to know that it uses PWM to control and rotate the servo. Okay. And inside the servo, as you can see, we have the gear. And as I mentioned before, over time, these can be worn. If you give it a lot of torque, what will happen is it's either going to siege it or you will break the gear. And when you break the gear, the servo is no good. So often that you see that because they're made with plastic, sometimes they break. And so it would be better if you have a secondary for replacement if you require that particular device. And it has a built-in potentiometer. And if you look inside the housing of the servo, you would see the actual motor, right, which comes up and it will rotate here, which turns the gear. And it has a built-in IC or what's called integrated circuit. So most of the electronic devices that we can program like this, or even on some of the LED or the LCD screen, actually has either built-in IC or a separate IC. Now the LCD screen that you receive in the kit, um, it doesn't come with the IC, but you can definitely buy one that has an IC built in, or you can buy an integrated circuit board separately for the LCD or other components. And they often showed it as the IC2, so it can be adapted to your actual circuit. And it's just what's the benefit of having the integrated circuit? Really, it reduces the amount of wires or the wiring that we have to do. So number one, the effort that you need to put in to really wire up your circuit. Second, it also allows you to have a better control of your device, and because it's going to go through that particular board. So as you can see, compare that to something that would require a lot of wiring. This one, it only needs three, and those three wires are going to go through the IC, and the IC is going to control the motor which rotates the gear. So think of the IC as a controller or its own board, right, for that particular device. And you see this in toys. If you ever open up like electronic toys and stuff like that, you would see small little boards. There are integrated circuits um, to be able to incorporate with these type of components. Now, for the electronics engineers, right, you often work with building something like this or understanding how this works in order to engineer different type of integrated circuits for different devices. So um, this is what you would see on the inside. And when you're looking at the wire for the servo, you would have a black and brown that usually indicates the ground, right? And it would have a female end, so you can plug your jumper wire in. And then red is always going to be positive, so that's where the power is going to come from to drive that motor. So that will be 5 volt. And then the yellow and the white is for the PWM. So the yellow or the white on the outside here. Okay. So you would then plug in the wire accordingly when you adapt that to either the Arduino or onto the breadboard. Okay. Any questions on servo? And after servo, we are going to get into some additional sensors. So starting tomorrow, you are going to work with capacitive touch sensor. And capacitive touch sensor, um, there are several. So I know every single one of you have used some kind of touch sensor. If you use a touch screen, it has a capacitive sensor built in. If you use your smartphone, right, it has a touch screen. Or if you have a lamp or some kind of device at home that you touch to turn on, it would have some kind of capacitive sensor that's incorporated. Is it necessarily exactly like this? No. You can have conductive material and use the software side to really make a capacitive sensor. So for your LED screens, it is incorporated with the OLED layer, with the light, and some of the device actually have the sensor incorporated within. Some of device would use conductive material, and then also integrated circuits and microcontroller to be able to do that. So if you don't have a board like this, right, you would require to have some other form of electronic board to really control or manage your capacitive sensor. Now, the one that you see on the right is the TP223. And this one, you would see that it has 3 pins. And you would see there's a light at the corner. When you plug it in and give it power, it will have an LED, it will turn on. The circular pad right here is the sensor pad. So when you touch it, you don't really need to press down on it. You just put your finger on top, just touch the top. It should be able to activate that if everything is connected properly. For the 3 pins on the top, you would have SIG for signal, and that's where you are going to be able to connect to the actual pin, like your digital pins. The VCC is for voltage source. And in order for it to work, we got to give it power, and it would normally range from 2 to 5.5 volts. So it's safe to give it 5 volt. So there, that particular connection is going to go to the 5 volt. And then the ground, as you know, all components would have positive and negative. So you would have ground. And so this is where we're going to go to your ground connection on your breadboard or on your microcontroller or Arduino. And so the sensor pad, as I mentioned, is the center of the module, and it would have an built-in LED at the top. Now, if you see the TP224 or something slightly different than this, the board is a little bit bigger and it would have multiple touch pads, like 1, 2, 3, 4. They would use that for something like touch keypads, or when you need to press different value at the same time or touch different area at the same time. So you would see something like that. So it's slightly bigger and it would have like 1, 2, 3, 4 section or area where you can touch. So you see some of the Arduino kit would come with those. And so you can buy something like this for very cheap. Okay. I bought a pack for like $5. So it comes with 10. Any question with capacitive touch sensor? So you would have something like this. Okay. And if they have it open, so this one comes with the anti-static bag. And then if you take it out, you would see that it would look like the picture of your on the PowerPoint. Okay, so you should have one of those that come with your kits or things that they gave you from iMake Innovation Center. Any question from touch sensor? Then next we're going to go into ultrasonic. So out of all the sensors, these are the ones that I'm presenting to you are commonly used. They're also my favorite sensor because you would find them in a lot of the things that we use today. Um, not necessarily in this form, but the technology is incorporated for a lot of things. So when you see those robot that vacuums people's house, the iRobot or, there are variations of it. Those smart devices, they would have some kind of ultrasonic sensor. This is used quite a bit for object avoidance. It works very well. Now this particular model, there's a limitation with the range. You would see other form like this for farther range. So when you're looking at like, automated cars to robots to different things, you often see some kind of sensor like this, the ultrasonic sensor being incorporated. So this is an HCSR04. It is known as the ultrasonic sensor. Um, it has like the two round, it looks like eyes, right? And you would see the four pins on the bottom, and the pins are usually labeled. So you have the VCC, which is for exactly like what we just talked about, right? Same as the other one. You have a trigger, you have an echo, and you have a ground. So this one has four pins. And how does it work? Well, what it does is it sends out waves or ultrasound, right, as the picture illustrated, and it's going to listen for an echo when those waves are bounced back. So this is why you have an echo pin. So as it sends out, if there's an object, it will the wave would then bounce back, and it's going to wait to listen for that. If it hears the bounce back or the echo, then it would know that there's an object that's present. So this is how your iRobot and some of those devices work, right? How it's going to avoid, tables and chairs and things like that. Not exactly completely avoid it, but not crash into it so hard. When it bumps into it, it knows how to back up because they program for it to be able, they instruct for that particular device to do that, right? So it pings the obstacle with the ultrasound. That means that it sends that out, and then it's able to, we can program it to really measure the distance from itself to the actual object. So if you program a robotic car and you want it to go from here to 1 meter ahead of it, when it reached that certain object, what it's going to do with this particular sensor is that it's going to ping the object ahead of it, and it's going to be able to listen for the bounce back to really assess the distance in between. So this is a really good sensor if you wanted to really measure distance, and it uses hence the name ultrasonic, which is sound, and we can incorporate, right, how it can calculate the distance from itself to the object. So now here, and you probably learned this from physics, right, or other math-based courses, um, you would have the time delay between the transmission for the sound that sent and received. So it's then be able to be used to calculate the distance. And your distance would be speed of sound times time delay divided by 2. And that's the formula. So we are going to do an exercise, right, on how we would be able to use a ruler. If you have a ruler at home, you can use it tomorrow. And you would take a piece of paper and you line it up with the ruler, and you would distance it from the sensor. And as you move the paper back and forth, it should tell you how far it is from the actual sensor is your paper. Um, so I was reading some thread online a couple days ago, and people were using this to do social distancing, limitations for workplaces, or it's a good way to kind of automate a lot of the things on how they would, set up like, businesses, waiting room, etc. So kind of interesting on what people would use technology, and this would probably be a good application for that outside of what we talked about with robotic or omatic devices and such. Okay. Any question on HCSR04, the ultrasonic sensor? This is one of my favorites. So, and you would see it. So I had done a project with it with the basketball hoop, um, and so my student and I, we hooked it up to a basketball hoop. Those toy ones, and then you can program it to count like the score, right? Like how you would see with the NBA, whenever the ball hit the basket and it goes through, right? You would have it count up so many points, and then you can have it where it from a certain angle, from a certain distance, so you can throw a 3-pointer, a 1-pointer, and so on. And the challenge with this is it's not sensing as fast as some, so you have to increase the sensitivity on it. Um, Otherwise, it won't be able to detect the ball drop because the ball is going to be dropping faster than how it's pinging the object as it's going through the basket. So we had some challenges with it, but it worked for some part, right? It needed a little bit more improvement, but that would be a fun project to do if you like to do one with it. Okay, the next one is your PIR sensor, and this is used for motion detection. This is really good if you wanted to create like an alarm system, so, or you can detect things on the outside. I had contracted or consulted a company that did some stuff in Malaysia, and what they did was they install this type of sensor, but in the industrial area, right around the railroad tracks. They built it so that way, when it sends like large live animal, it would notify, it would send some kind of signal, and then they would have, because they were trying to protect some wildlife in the area where the train was passing through, because there were tigers and elephants and things were getting killed. Um, so something like this can be incorporated in so many different applications, but the often um, you would see this in using for security systems. Okay, so you are going to do a couple of things with it today. So how does the PIR work? What it has inside this white dome is your pyroelectric sensor, and it has the second part, which is the Fresnel lens. And what it does is it's going to be able to read or detect the infrared radiation. And so now when you're looking at human, right, we are alive. So we would have some kind of, it will be able to detect us, because, if you ever use like infrared camera, or, night cam, or if you have security system that does that, you would see that we would generate heat, and we would have some kind of infrared radiation around us, so therefore it will be able to detect that. So um the two main thing that you would know is that it uses the pyroelectric sensor. Okay, and then inside that it's also used a Fresnel lens. And if you enlarge this picture a little bit, you can see, so the Fresnel lens is back here, and then it's going to be able to detect if something is there, right, uh, based on how it sends out the the signal. So there are two things that we would look at when we're working with this type of sensor is how sensitive it would be. And so the maximum distance that you can use this with is about 7 meters at the max. So between 3 and 7 meters, it will work best. So for something that will be very lengthy in distance, this might not be the good sensor for. Okay. So 3 to 7 meters, that will be the range. The time, so it would require about approximately close to 3 seconds, and it can go up to 300 seconds for the detection, or 5 minutes. So is that going to be slow or fast? In general, you're going to see that if it's closer to it, you're going to see that it's going to be a little bit faster than compared to when it is a little bit farther from it, where it could take up to a few minutes before it get triggered. Okay. So when you look at the sensor, you would see 3 pins. You're going to have a VCC on the left, that's pin 1. And then you're going to have a pin out. This is going to be the signal control one, right? And then you're going to have a ground, okay? So VCC is used for the power supply. That's going to be your power source, your voltage source, right? So that's where you're going to connect the 5 volt. And for your output pin, that's usually the 3.3 volts logic output. And so low is going to say that means it doesn't have any motion detected. High, it's going to be that it's detecting some kind of motion. And then your ground is going to be connected to the ground connection on the microcontroller. Okay. So any question on PIR sensor? And this one is the SR501. So sometime when you look at PIR sensor, this will pull up, but to be safe, you can type in HCSR501 and you will find it for sure. And there are variation. It doesn't have to look exactly like this, right? And there are other PIR sensors that are better or not, right? So depending on the model. Okay, so just before we start, we need to make sure that we set our COM port, right? After you assemble your circuit and everything, when you plug your Arduino in, make sure that in your IDE, you need to check your COM port, select the one that says Arduino on it. You need to make sure that your board is set up properly where it recognizes as Arduino Uno. Make sure that we check syntax. So when you're typing, make sure that you look for typo or mistype. Use a semicolon at the end of each line. Check your parentheses. So make sure that all your open parentheses have closing parentheses. The same thing with the curly brace. And then you can save your code. That will be saved to your system. And just look for errors and try to read errors. So it's, if it's like board or some kind of error that pertain to board communication, check your ports or check your driver. Okay. So as we are going to work more with the equipment, just keep them organized so you know where to find them and just make it easier on yourself. Um, and we are going to be using male to female jumper wires. We are going to use these sensors, so and LEDs and buttons and buzzer and so on. So just like what we've done in the last week. Okay, so we are going to do week 2 assignment and then for today and tomorrow, and then we'll work on the lab for Wednesday and Thursday. Okay, any question? All right, so let me go through what you have to do today. I know some of you might have gotten started. So this one is very easy to do. I wanted to start with an easier one, and then we will work toward more complex one down the line. So we are going to use the motion sensor and we are going to make a basic motion detection system. Okay. So this one, you don't really need a breadboard. You can adapt it to the breadboard if you like. Um, you can plug it directly into the Arduino, which I did. Okay, so let me move this over here. And so this is how it would look. Okay. So the long leg of the LED is going to go to pin 13, just like the first exercise you've done in this class, right? And you can use red or blue. um, the yellow, the green sometimes is kind of dim, to hard to see, but blue is pretty bright. And then you're going to have the ground, which is going to be your short leg. Okay, so you can plug the LED directly into it. And then you are going to take a PIR. Okay, and on mine I have orange, yellow, and brown. And what I like to do too is I like to stick to the color coding scheme so I don't confuse myself. Okay, so you can use black, red, and yellow if you like. And on this one, you would use a female connector. Okay, so when you plug it in, so when you look at this, on the opposite side, you would see like two, sometimes this is blue or a different color, right? Like it has like a cross, looks like the screw. Okay, when you turn it the other side, okay, when you're facing it, just like how you would wire the way that the diagram is showing, right? Your red is on the left, the middle is going to be your yellow, and that yellow is always going to go to your digital pin, the middle wire. Okay, the positive, or your red, the one on the left, is always going to go to the voltage side. So we are going to plug that to the 5 volt. And then of course your ground, which is the black or the brown, that's going to go into the ground connection on the Arduino, which is next to 5 volt. Okay, and it's very simple. It should take like a minute to kind of put everything together, hook it up. Any question with the schematic? Okay, so once you set everything up, then you are going to open up your IDE and you are going to program. So you can write in the program that's shown. And so I'm going to go through this while you put everything together and add your program, write your sketch. So at the top, we simply declare your variable, and you can use const int, or in this case, we just use int. That's okay, right? Technically, we can use const int, which is constant integer type variable. And so for the LED, since we plug it into digital pin 13, we would then declare our LED pin 13. And then the digital pin 2 is going to be for your PIR sensor. That will be your yellow, right? Your yellow connection, the middle wire. And by default, we want to have the state as low. That means no motion is detected. Earlier, we just touched on that, right? So you have to initialize the state, and the default state for it is no motion detected. Okay. And then we have a variable called val, and this variable is going to store the value, or it's going to update the status as it sends whether there's motion or not. Okay. So just like before, we are going to output LED. So we are going to use pin mode and then bring down the LED variable, and we're going to output. And we want the sensor to initialize the input. So sensor pin is 2. So we're going to use that in the argument here, and we're going to say input. So that way it can receive signal. And we are going to use the serial monitor. So for line 14, we would say serial.begin, and the baud is going to be 9600. So that means that after you upload the code, you need to open up your serial monitor so that way you can see whether it's output or not, whether there's motion detected or not. Okay. So in the voice setup, we're going to set up these, your LED, your sensor, and your serial monitor. Then in the next part, I don't believe I have a female to male jumper wire. Okay. You don't have it in your kit? Check in your electronic component bag. Um, if you don't have it, this is how you can do it. Okay. You can adapt it to a breadboard. So instead of hooking it directly like this, okay, I'm gonna stop share so you can see my camera. Okay. Um, instead of hooking it up like this, where you would have a female pin, what you can do is you can use male to male jumper. You would then plug it onto your breadboard. Okay. And then you would then bridge it. So you would then connect it back to the Arduino. Okay, that's how you can connect it. So what you can also do, let me take a breadboard, I can show you can plug the PIR sensor directly onto a breadboard. So let me get a breadboard here. Okay, George, you see these 3 pins? Okay, what you're gonna do is you can plug it directly onto here, but it's gonna, see how these capacitor, okay, sometimes so you will have to play with it. So you can technically plug this directly in, but it's the capacitor sometimes is in the way. So it's better that you would use it where you would have a male to female jumper wire. I will let Abraham know. Another also workaround is if you have electrical tape, you can use it. So you can tape the 2 ends together as long as the conductive metal touch. So what you can do is you can take a jumper wire, okay, like this, and then you would have to rig it a little bit. So that means that you will have to tape it as they are touching like that. Okay. So you should have, you should receive the female to male. I have asked for that. So if they miss that, I will let them know. And if you want, you can come and pick it up. Question. Now these the capacitor, right? Sometimes they're loose, but you see them on motherboard as well. So don't let them fall off though. Okay. Yeah, on this one, it's a little bit harder to connect, but I was able to connect the other sensor, as you can see, directly onto the breadboard like that. Okay. So if you can't get some of the things done today because you don't have a female to male jumper wire, that's okay. We can wait until when you get your jumper wire. Okay, so after you hook everything up, right, you program it. Let me plug my Arduino in. Okay, so in the loop, you are gonna have it read, and it's gonna store the read value in sensor. So we're gonna pass the sensor variable here, and we would have the condition. There's 2 ifs, so that's a nested if. If value is high, that means that if it detects motion, right, it's going to turn on the LED. It's going to wait 100 millisecond, okay? Then we have a nested if. So the second if said that if the state is low, that means that if uh, if the state is low, then we would have serial print motion detected and state is going to be high. So it's going to tell us that the motion is detected, right, if it is high. Okay, it's going to update the variable to the high state. Else, then it's going to turn off the LED, wait 200 millisecond, okay? So it would turn off the LED if there's no motion detected. And then the last part, if the state is high, then it's going to print line motion stop. Then it's going to update that with the low, right? And then that's basically our program. So the way that you would test it is after you enter your code, you check your port, okay? And then, so now you can angle your sensor, okay? So but first you need to make sure that you're on the right port here. And then I'm gonna go ahead and upload my code. Make sure I have no error, okay? And then I'm gonna turn on my serial monitor, okay? And it tells me that motion is detected, okay? And you can test it a couple of times. So, and you can play around with the program, change the wait time, modify the state, etc. Okay. So on this one, it simply just gives you the LED. Now I'm turning my head, right? As you see that white dome, right? The lens is a curved lens, so it's able to see around it, not just in front of it. Okay. So now if you put it in an area where there's nothing moving, right, it would then tell you that it's, it would turn off and there's nothing detected. Okay. Any question? So this is just the initial state in how we would do a motion detection security system. And this one is an easy one. So let's unplug that. Any question? So George, maybe you should also check in the Raspberry Pi box to see if you see anything in here. I took the box pretty new, though they didn't add anything. So yeah, if you don't have the male to female ones, you can wait to do these two after, but you will need it for this week. Okay. Stop by there to ask for some. I would ask them for at least like 10. Now, if you buy like these kits, sometimes they don't have them. Most of the time they have only regular male to male, right? You can also buy them bulk and they would come and you would tear them off like that. They come in different color. So I bought like a combination of both for like a few dollars from Amazon. Okay. Any questions? Good. You guys, it shows David got his working. Is anybody having any problem with that last exercise? Okay. All right, let's touch on the next one. So part B, we are going to elevate our security system, and this one we're going to make it sound. So you are going to use PIR sensor again. Okay. And at the beginning, it just talks about what we covered in the lecture. It uses Fresnel lens, and that's a way that it can detect infrared. And it tells you here that the lens on the sensor focuses on any infrared radiation present around it toward the infrared detector. So if your body generate infrared heat, and that heat is detected by the motion sensor. So if you're looking at like animals, that's also generated infrared, human being, right? Um, and the sensor outputs 5-volt signal for the period of time of like about a minute or so as soon as it detects the presence of a person. And so if there's no movement, right, the slots detected the same amount of infrared radiation, resulting in a 0 input signal. So if it detects it, it's going to generate a 5-volt signal. If it doesn't detect any kind of motion, it would generate a 0-volt signal. Okay. And so human body, animal passes by or nearby, when it intercepts, right, half of the PIR sensor, it would cause it to be a differential change in the two halves. So that way it would then generate a negative differential change. Now, it would then only be able to sense, as we talked about earlier, best would be between 3 meters to 7 meters. Okay, maximum of about 7 meters. That would give it, that would be high in sensitivity. So for the next one, you are going to need Arduino USB, male to male jumper wires. You should also use female to male if you have it. You would need a PIR sensor, a breadboard, an LED, a button. You need a buzzer, which is the speaker. You can use 220 ohm or 330 ohm resistor, and you need to adapt 10K ohm resistor. I'm sorry, 1K ohm resistor. I think I use a high resistor. So it works. Okay. So when you connect, you would connect the 5-volt and the ground of the PIR to the Arduino. So I have mine as red, and the red, if you follow the diagram, the red would then be on the positive, okay, the positive of the breadboard, okay. Then I'm going to bridge it. So then I'm going to bridge that positive connection to the 5-volt. So another red cable. Then you're going to connect the VCC with the positive. So that's my red. And the ground, that's the black or the brown. And then we're going to connect it on the negative side of the breadboard, the other side, the negative side right here. Okay. And then for the yellow, I'm going to plug the yellow or the middle connection to this pin 7. That's going to be your digital pin. Okay. Then the LED, the shorter side is going to be for ground. The anode, the longer side is gonna line up with your resistor, and you can use 330 or 220 ohm. Then you are gonna connect the second pin of the register to the pin 6, okay, as shown in the schematic. For the buzzer, make sure, because you're using a large buzzer, which I try to use, so we just gotta make sure we line the leg up, right? So for the negative, that's gonna connect it to the negative side of the board, because then we would then bridge it to the ground. And then for the positive, make sure that you line that with the buzzer leg, okay? And that positive is gonna go into your pin 5 for the buzzer. So I use the orange for that. Then you're gonna have a button. So, and the button, you can use 1K ohm there, and so it has 4 legs. So the bottom leg is gonna be next to the resistor. The top leg is gonna connect to pin 12. That's gonna be your button digital pin, okay? And then we can bridge the positive, the BCC with the positive side here, along with the positive of the button. Okay. Any question as far as the schematic for the second one? I'll let you work on that for a few minutes. So as you can see, the alarm sounds off. I'm gonna unplug it now because it's gonna be really annoying. Um, and you would have the LED blinking, okay? So as you work on the schematic, I will talk about the code here. So at the top, we have the variable to declare our pin. And so if you're not sure which is which, you can also look at your code, right? Your buzzer pin should be pin 5. Your LED should be connecting to pin 6. That's the longer leg, right? Your PIR, that will be connecting to pin 7. Your button pin, that will be connecting to pin 12. Okay. Now on this one, it's a little bit different than all the other programs we've been doing. We're using a Boolean type, and Boolean has either true or false. Okay. So this is going to be the buzzer mode, where that's going to be its state, right? So we would initialize it as false. So you would have Boolean, and then your buzzer mode is a variable, and we would initialize it as false to start. Okay. Then we also have variable for our LED state, low for off. Okay. And then on this one, we wanted to store the millisecond. So we would then first initialize it as 0, and it's going to update. And the interval for the blink in between on and off, that's going to be 100 milliseconds. Okay, and this is going to be for your LED. So after we had set up our variables, then we are going to work on void setup. We are going to output for the LED, just like the last one would just use a different variable name. We're also going to output for the buzzer. And then, but for the button, we wanted to receive the input. So when that button is pressed, right? Same thing like we've seen in the past last week. We wanted to receive the signal from the input for the button. So all three of those use pin mode there to have output and one have input. So it would then wait 5 seconds before starting the alarm. Okay. So in the house, if you think about like a household security alarm, right? It normally gives the people what 60 seconds to set the passcode. If the passcode is not set, then it will sound off, right? It will buzz. Um, so we can extend this to a higher milliseconds value, and then you can also incorporate additional criteria with that, right, in the loop. Okay. So for the loop, sorry for the typo here, we would then check if the motion is detected. So we would have an if statement. Okay. So if it's going to read, it's going to have if its motion is detected, then it's going to activate the buzzer. So that's going to become true. Okay. And also if we have a nested if it detects motion or if it buzz, then it's going to activate the blinking for the LED. Now the unsigned here just means that it is not a negative value. So that means it's a positive value, and long is the type. It's just able to store a longer number in that variable, like in the thousands, okay? Compared to what we would normally see a couple of few digits. So you would use the long type when you have a larger number. And in the if statement, we would nest another if, okay? And that's going to allow us to change up the blinking, right? Uh, we would have the interval. So we would check the condition. If the current milliseconds subtract the previous millisecond is larger than the interval, then it's going to update the previous millisecond with the current millisecond. And then if the LED state is off or low, it's going to update that with high. So if it turns off, then it needs to turn it back on. Otherwise, right, turn it off. Okay. Then after that, we would have a digital write. So it needs to switch the LED. So we would then pass the pin, which is 13, and the state. And then for the buzzer pin, that's the digital pin for the buzzer connection and the length for the tone. Okay. Then the next part, that will be alarm off. Then if it's false, then it's not going to have tone, so no tone for that buzzer pin. And then it's going to switch off the LED at pin 13. Now, since we incorporated the button, we got to incorporate the button state. The button state is going to be what the signal that's read from the digital button pin. So if it's pressed, that means it's going to be 1. If it's not pressed, it's going to be 0. So if the button state, that's going to be in, if it's not pressed, then it's just going to be false. Okay. And once you had set everything up, enter your program or your code, your sketch. Make sure that when you plug your Arduino in, make sure that you check your port. Upload the program. Check to see if the LED is working, if it's buzzing. If it's not buzzing or blinking, that just means that we connected something incorrectly. And I followed the schematic to the T, so it should work accordingly. Okay. Any question? Now on this one, we didn't have the serial monitor. And so if you want to have a serial monitor, you can follow the format of the last one. You need to, in the voice setup, you gotta have the serial.begin 9600 baud. And then in your loop, you need, under specific condition, you need to, logically, you need to think about, like, if motion is detected, then I wanted to show some kind of text, warning, or whatnot, right? And it's buzzing, right? If motion's not detected, then you can say no motion detected. So you can add the appropriate string accordingly. You just got to tell it where. So logic wise, we have to put it in the right nested if condition. Okay. And then when you plug it in, so after we upload it already, right, it should automatically work, right? It should wait 5 seconds, and then you're gonna get like the buzzing noise and the blink if you get motion detected. Okay, like that. And you can tweak it a little bit, you know, you can expand it, you can play with it a little bit. So when I tested this, I've done many of the security type of alarm system with Arduino. There were like 6 different projects that I looked at. Um, so this one's pretty good. There are other ones that use potentiometer. Okay. And then you can also adapt this. If you look at your Arduino book, there is one in there. You can also adapt this with an LEDs or LCD screen. So you can plug the LCD in and then wire it, which you are going to see on the next one. And so if it's motion detected, you can have it display on the LCD, but you have to bring in the LCD library for that. Okay. So this one is a simple one that you can see the transition between the first and the second one. Okay, any questions or any problem with this one? Okay, so as you complete both of those, you can take a picture of them. That's what you're going to use for assignment submission. So no question? How's everybody doing? I see David is working. Now, if you don't have the wires, you can also work on some of the other activities, so you don't have to do them later. Okay. I know for the next one, you don't have to have a female to male jumper wire. You can all use all jumper wire, but you require quite a few. Okay. So as you can see, as we advance to more, we adapt more components, especially the LCD. Um, LCD requires a lot of wires if you don't have an IC, if you don't have an integrated circuit. And the LCD that we're using is 16 by 2. Okay. So what am I talking about on the next one? Okay, I should finish that. So if you just Google like integrated circuit LCD, so this is an LCD, right? This is from Adafruit. They sell it like this. So on average, it would run about like $10, $11. Your kit comes with it. It's like this in a box, right? A rectangular box in the Arduino kit. Now, some of them would come like this. Okay. So on these, you see how it has the integrated circuit built in already. And these ones come with the cable. Okay. So you can attach. So this one already has the IC built in compared to the other one, like the one we have, doesn't. Okay. They would have the pin out like this. And then on the strip end, some of them don't even have the pin out. Then you can buy the pin out and solder it on. Okay, so these are already pre-soldered for you. Any question on exercise A and B on the PIR? No. Okay, since we have a little bit of time, I'm just gonna lead you into the tomorrow. And then that way, hopefully by Wednesday, we will finish everything, but I will still put up a little recorded video on the next part. But for the lab, just remember that we are going to use cardboard box. So if you have a small cardboard box, like a shoe box or something small, you can use it. Um, and then we are going to use conductive material. So if you have like a bunch of spoons, that works well. A pack of soda, that works really well too. Fruits will work. Okay, so for your piano key, and then of course Play-Doh is conductive. So that's what we're going to be using for the lab. Okay, so for part C, we can get started on this and then we'll finish it tomorrow. You are going to use HCSR04, and on this one, we are going to measure distance. Okay. So this particular sensor would emit ultrasound at 4,000 hertz or 40 kilohertz. And so just as far as range goes, right, um, you do have some detection range limitation there. Okay. So it's going to be detecting between 2 to 400 centimeter. That would be best. Okay. And the angle would be that it would be approximately 15. It's going to be less than 15 inch. Now uh, for the pin, we already talked about how it would be VCC. So the first one is going to be your voltage source. The second one is going to be your trigger. The third is going to be your echo. And the fourth is going to be ground. So unlike the other one, you have additional pins for this one. Okay. So the VCC is going to be connecting to 5 volt. You are going to connect trig and echo to a pin, and that could be any of the digital pin, but we would then refer to how we program it to be able to connect it correctly. Okay. So when it sends object, it's going to transmit, and then it's going to wait to listen for the reflected signal. So this example, it shows you 10 centimeter. Okay. So how they calculate the speed of sound, or for the time, that's going to be distance over speed. Okay, and so here you can see the formula. And the comma here, it's just that will be equivalent to our period, right? That will be 0.034. This is European style. That's how to use comma instead of period there. Okay, so if you finish with the other two, you can work on this circuit. It does take a little bit of time. I don't think I have all the pins connected on this one either, but I had set this up already. Unplug this. Okay. So what you can do is you can take the LCD and you can attach it to your breadboard. Now, if you have the long breadboard, that will be beneficial, but if they give you the short one, it's going to be a little bit limited to work with. But you can connect everything onto one tiny breadboard. Um, or if you don't want to connect it to the breadboard, you can also use the female end of it to connect to the pin of the LCD. Okay, you can do it that way. Now, they do sell like the larger screen for Arduino LCD. This is the 16 by 2. You will also need a potentiometer, the one that we previously used last week. Jumper wires, you are going to need the SR04. Okay. And what you should do is you should have a ruler. Okay. So once you finish everything, you would set your ruler underneath your breadboard, and you would take a piece of paper and you can move it back and forth to see if it's actually showing the distance in centimeter on your LCD. Okay, so that piece of paper can be in front of your SR24 or SR04 there. And I also included the tutorial for the YouTube. This is through a channel. There's an instructor. He teaches everybody, on Arduino. There are different lessons, kind of like what I'm doing, but in a regular class. Um, and he had a YouTube channel. So I had gone through testing about 6 of these. And this one is the best one. So this is the one that was selected for you. And so if you wanted to watch his YouTube, you can also find that here. Okay. Now, as you plug everything in, you can also check your code as you go through, right? You're setting the trigger pin at 13. Your echo pin is at 11. That's going to be your sensor. So in the back of it, you can plug it into the back. Just make sure that you line up. Make sure that you line up the jumper cable to the actual pin accordingly. And then the other end, you would then plug it into the proper pin. Okay. So since you're using LCD, you need to include liquidcrystal.h. Okay. And then you need to specify the pin, right? Since this comes out of the liquid crystal library and the LCD object here, you would then access the pin by passing it in the parameter here. So 10, 9, 5, 4, 3, and 2. Okay, and so when you check your LCD pin after you plug it in, you should check those. Okay. There's no connection for pin 6, so technically you can comment out the servo control pin. So I think on this one, it's supposed to also connect a servo based on the code. Okay. But when I looked in the diagram, there's no pin 6. 6 and 7 are open. Now your ping time and your target distance, that will be decimal points or floating points. So it would be using the float type. Okay. And then your speed of sound, here we would then initialize 776.5. That will be the speed of sound of miles per hour when the temperature is 77 degrees. Okay. Then we also set up our serial monitor. So serial.begin. And then for your trigger pin, we want it to output. For the echo pin, that needs to be input because that's the receiving, right? This is the out, this is the in. So since we are using 16 by 2 LCD, that's 16 column by 2 row, we need to tell it that will be 16 by 2. Okay. Now, because it's a placement, so the cursor where you want it to start on that screen, if you program output text on display before, you would know that you have to really position this at a certain area of the screen, and we would start with 0 by 0 at the upper left corner, because in our culture we read from left to right, right? But in a different culture where they read from right to left, then we would then have to position it at a different value here inside the parameter. So keep that in mind. Like for the English language, we would look at the screen, and in technological design, right, when we're looking at designing applications or system, right, people would look from top down, left to right, right, in most culture. So you would then think about how you would position your cursor to start your text at 0, 0, top left. Okay, so column 0, row 0. And then it needs to start with the string target distance. So it's going to print the text. And so if you look back at the picture, right, it's going to show this here. And 0, 0 is going to position the cursor here. So it start the T there and it display across your string. Okay, so think of it like a grid. Okay, so you want it to start at 0 by 0 and then display it across. Okay, so we would have 16 columns and 2 rows. Then in the loop part, we would then have the trigger pin, right? So we would first set it to be low, okay, for off, and then wait 2 seconds. So we are going to delay it by 2 seconds, and then we're going to set that high for the trigger pin, turn that on, wait for 15 milliseconds, then low again. So once that's sent, we have to wait, delay the high state. So here our ping time is gonna be microseconds. If you recall earlier in the picture of the sensor, it shows the microseconds. So for our ping time, we are gonna receive the signal, right, through the echo pin. And then we need to convert it. So ping time is gonna be ping time divided by this, okay? So 1 million microsecond. Then we also need to convert that to the number of seconds for the hour. So 3600. Because earlier we mentioned that it's the speed of sound, right? So your distance would be speed of sound times ping time. So you would then bring down the value for speed of sound, which is 776 point, what was it? 0.5. And then we will multiply it by the ping time. So that's that's going to give us the distance as in miles. Okay. Then we have to take the target distance divided by 2. Recall the formula that we see earlier up here. Okay. So we would then divide that by 2. This is a perfect exercise for physics class. All right. Then we're going to have to convert miles to inches. So we would then take the distance multiplied by 63,360. That will give us inches per mile. Then we wanted to move down to the next row, right? So we would then be in first column, second row. Then we are gonna print blank to clear it first, and then set the cursor at the same location again, and it's gonna display the target distance. So that's gonna give us this line right here once it's calculated, okay? So for you take the cursor, clear it, and then it's because the variable, right, stores the calculated value, it's gonna display that value here. Okay, so that will be your target distance, which how we achieve that through different calculation there, and we can through the conversion. So we would have that here. And then we would then have it printed out in inches because we convert that last from miles to inches. Then it's going to pause 250 milliseconds. Okay. And so as you move the object farther from it, right, it would then give you a different reading value, and you would use your ruler to check against it. So put your ruler underneath your breadboard, and then take a piece of paper or what you have on hand and just move it back and forth on, measuring with the ruler, and so you can see if it's accurate. Any question? Now you can definitely use this one for security alarm as well. But this one will be good with distance measurement, distance or object avoidance, and so on. Okay, there are a lot of different projects using this particular sensor. Okay, so if you don't get to finish this one today, that's okay. We'll pick it up tomorrow. And then I will lead you into this one tomorrow. We'll do the capacitive touch sensor. And then if we have time, we'll get started with the lab early. Okay. All right. Any question for me? No question? Let's see who's here.
I have a
Yes.
question.
Yeah.
So
Sure.
I've been using electrical tape because you said electrical tape